Good afternoon. Welcome to an educational video that is being produced on March 30th, 2014. Today we're going to talk about instability and heavy rain production. And I thought this would be a perfect day to discuss this aspect in terms of how to forecast for these events and what to look for. In this case, what we have right now is some very heavy rainfall setting up from about east central Pennsylvania on south through Virginia, and some very intense rainfall over portions of southern Pennsylvania, southeast Pennsylvania, really, south central, definitely all of Maryland. This is impressive here. Now, some of this is due to some sleet. So what gives here? What produces this type of event? What causes this type of sharp cutoff here? Well, the key aspect here is basically an upper level low. And that upper level low has a pocket of cold air. And I'm going to show you in just a few minutes how that pocket of cold air lines up to produce this type of rainfall signature and this type of heavy rainfall and even some snow. So on the infrared satellite picture, you can see an area of enhanced lifting. Now we know it's an area of enhanced lifting because of the cloud tops. Notice how this is blue and this is yellow. We even have a few oranges here. Remember, the colder the cloud top, the higher the cloud top is in the atmosphere. The higher the cloud top is in the atmosphere, the stronger the lifting. So in this case, what we have here is some very impressive lifting developing over southeastern Pennsylvania and south central Pennsylvania. And we know that because the cloud heights are rapidly building and expanding up into the atmosphere. So what's causing all this? Well, let's take a look at some of the SPC data. We start off at the surface here where we have an area low pressure that has rapidly deepened down to 996 millibars. Pretty impressive for this time of year, that is for sure. We also have a very strong pressure gradient. That's going to lead to some very windy conditions. But let's go up a little bit more into the atmosphere at 925 millibars. Now this is where it gets interesting because what we have here are several different gradients of temperature. We have our cold pocket here in east central Pennsylvania, basically building down from the St. Lawrence River Valley down through central Pennsylvania and then building into portions of northeastern Virginia. We have our 925 millibar low off the New Jersey coast, and lo and behold, look at this. This is our gradient. Now this temperature gradient here at 925 millibars matches up very nicely to the way that the rainfall is setting up as a gradient here. So this is driven by a temperature gradient. But we need to go a little bit further up in the atmosphere. We got one part. Remember, you have to look at all parts of the atmosphere. And also keep in mind, we have very warm temperatures out here in the Ohio River Valley. So this is clearly a cold pocket of air, not a dominant cold air mass like what we see during the winter. Next, let's go up to 850 millibars. Now, at 850 millibars, notice that the 850 low is over the New Jersey coast. A low pressure system is allowed to strengthen when it's not vertically stacked, which is when one low is over the other. What you want to see here is the surface low here, 850 millibar low here, 500 millibar low here. When they become vertically stacked, which is when they're all over each other, that means there is no more thermal gradient in a horizontal plane. That means the low pressure system isn't able to intensify because everything's just getting shut off, kind of like a shutting off the chute in your chimney. The smoke, the air cannot continue to rise. So what we see again here at 850 millibars is that intense thermal gradient set up over east central Pennsylvania, lining up again perfectly with the heavy rainfall that is set up over east central Pennsylvania. So this is driven by the fact we have a cold pocket of air combined with very strong thermal gradient along the coastal plain. So the combination of those two factors, where we have strong warm air advection, warm air transport into the coastal plain, and this cold pocket of air on the backside of this upper level low, leads to that intense thermal gradient. And by the way, note these strong winds here. They're going to be able to get mixed down, and those winds are going to lead to wind gusts over 40 miles per hour as a result. Meanwhile, another important aspect here, see how cold these temperatures are? -3, -3 Celsius, -4 Celsius. Key point here, the fact that these temperatures are so cold means that the higher elevations, we're talking above 1,500 feet, will be capable of seeing some snowfall. I know, it's crazy, but it's true. And as a result, because of these higher, I mean very much higher elevations, you could see an inch or two in this type of scenario. It's not out of the question. Not a snowstorm, but certainly something you want to warn your clients about if they're on top of a mountain, which is pretty rare, but still. In this type of situation, though, the driving factor here is as this upper level low lifts to the northeast, this thermal gradient is going to shift east with it. And that's why this evening you're going to see very heavy rainfall over the Philadelphia metropolitan area, all of New Jersey, and later on to the New York City metropolitan area. Now, considering that, always remember, as the sun sets, the instability weakens because the difference from temperatures at the surface to the mid-levels starts to decrease. So that's always a factor as well. So let's say, for example, if there were thunderstorms popping up behind this upper level low. Well, these thunderstorms would only last for as long as the atmosphere remained unstable. In this case, this heavy rainfall will only last as long as the atmosphere remains unstable. So as the atmosphere cools and as the sun sets this evening, look for these intense rainfall amounts to start to back off a little bit as the instability at the mid-levels starts to decrease. Finally, we'll look at 500 millibars. And what I want to show you here is again the placement of our upper level low. 500 millibar low down here. We have a very strong jet streak that is developing. And of course that supports the development of strong lifting and divergence here over northeastern Pennsylvania, thus leading to our instability setup. Another aspect I want to show you, and this is kind of important, 850 millibar phronogenesis. Now remember I talked to you about the thermal gradient that's setting up? Here it is, right down central Pennsylvania. Go even further, 700 to 500 millibar, notice it starts to weaken. So you can see the influences of what type of lapse rate can be developed here. Now, at the surface, we don't really have much of a strong lapse rate. Usually what you want to see are temperatures in the 70s to really have this really take much of an effect. But let's take a look at the mid-levels for a second. And look what we have here. A lot of instability in the mid-levels, and that's what supports your heavy precipitation. So my point here for today in this educational video is that you have to look at every level of the atmosphere. I see way too often people pulling out snow maps just considering 850 millibars, or pulling out information that only looks at one level or QPF. You have to look at everything, because if you look at everything, then you get a true three-dimensional idea of what the weather is actually doing. And when you develop that three-dimensional idea here, that is when you start to get a better idea of what's going on with the weather and how weather systems develop. So you could think today's heavy rainfall, at least this evening's heavy rainfall, on mid-level instability and a pocket of cold air at 925 millibars. Hope you enjoyed today's video, educational video. Of course, I'm your meteorologist, Stephen D. Martino. Have a wonderful day out there, and as always, stay safe out there.